Hello everyone, welcome. In the episode 1, we built a line graph multi-agent pipeline that produced a structured report. Each node returned a Pydantic model, each piece of data at a time. Nothing escaped as a raw string. In this episode, we are wrapping that kind of thinking in a production API. Because here is the gap I see most in their integrations. Teams put serious work into their LLM pipeline and then they expose it through an endpoint that returns raw string. Whatever the LLM said, the client receives. If the model confabulated, client receives that too. If the output is missing a field, client finds out at the runtime when it tries to access it. The fix is not complicated. FastAPI has response model, Pydantic has validators, Claude has structured output via tool use. These three things used together create a service boundary that the LLM cannot cross with malformed data. That is what this episode covers. We are going to build a title enrichment API. Given a movie or product title, return structured metadata, genre, summary, confidence score, any warnings. Every field is typed, every response is validated before it leaves the service. And the test strategy checks structure and thresholds, not exact content. Let us build it. Before we write any code, I want to show the exact failure mode we are solving. Here is the pattern I see in most first version AI integrations. You call the LLM, it returns a string, you pass the string to the client, your frontend, your downstream service, your database write, and your system now depends on the LLM consistency, returning a string in the right format every time under all conditions. This is a fragile dependency. LLMs are not deterministic. The same prompt can produce slightly different output on different runs. Model versions change. The model gets confused on edge cases. It adds extra text before the JSON. It returns a list when you expected an object. It omits a required field because the context was long and the instructions got deprioritized. If your API boundary is string, none of these failures are called. They propagate into your system. Your frontend crashes trying to parse JSON that throws in front of it. Your database write fails because a required field is null. Your user sees a 500 error. The right fix is to enforce the contract at the service boundary, not in the client, not in the frontend, not in the try-catch buried 3 levels down. At the service boundary before the response leaves your API. FastAPI with Pydantic response model is exactly that enforcement point. Let me show the full architecture before we go inside each layer. The architecture for this episode has 3 layers. The first layer is the API layer. FastAPI route that receives a typed request and return a typed response. The route signature is the contract, what the caller must provide and what they will receive back, with no ambiguity. The second layer is the LLM layer. A Claude call with structured output enabled via tool use. Claude does not return a free-form string. We give it a JSON scheme, derived from our Pydantic response model. It returns JSON that matches all the schema, every field, every type, or the call fails. The third layer is the validation layer. Pydantic validators that runs after Claude returns but before the response leaves the service. These catch the edge cases that slip through even with structured output. A confidence score of 1.5, a generous list that is empty when it should not be, a summary that is technically a string but is only 2 words long. The data flow is clean. Request in, Claude call with typed schema, Pydantic validation, response out, nothing unvalidated ever leaves the service. Let us start with the Pydantic model, because they define the contract that every other layer enforces. I design the Pydantic models before I write the role, before I write the Claude code, before I think about prompts. The models are the contract. Everything else is implementation. The first is enrichment request. It has a title field, the movie or product name, a string, and a context field, a short hint like film distribution or e-commerce electronics that helps the model disambiguate. Both are required, no defaults. If you call this API, you must provide both. Let's go inside the code and see them both here. Enrichment request is here. It validates inbound request, and enrichment response is here. Output response. Look at this line, model config. It rejects unexpected color fields and strip reject and blank method strip leading trailing white space and reject strings that are blank after stripping. And this is the enrichment response. 3 validation gates fire before this leaves the service. Gate 1, Claude tool use. Schema enforces the types. LLM boundary. Fields validator enforce business rules. Non-empty genres, clean items. Model validator adds cross-field warnings. It's a low confidence flag. Look at those validators. The enrichment response. It has a title, a code back from the request. It has genre, a list of string, at least one required. It has a summary, a string, 1 to 3 sentences. It has a confidence, a float between 0 and 1. And it has a warnings, a list of string, empty by default, for cases where the model is uncertain or the input was ambiguous. The last field, the warnings, is a pattern I want to highlight. Most APIs either succeed or fail. A warnings list let you express a third state. I returned a result, but you should know this input was ambiguous. Or I found only partial matches. That is useful information for the caller to have. It is much better than silently returning the low quality output. With the models defined, let us wire up the Claude call. And this is where structured output does the heavy lifting. Claude supports structured output via tool use. The idea is straightforward. Instead of asking Claude to run JSON please, you define a tool with a JSON schema, and Claude's response is a tool call, a structured JSON object that matches the schema you provided. This is meaningfully different from prompt engineering your way to JSON. With prompt engineering, the model might comply 95% of the time. That 5% is your production incident with tool use. The model is constrained at the production level and the protocol level. If it cannot produce output matching the schema, the API call fails, which is information, not silent bad result. Here's how we implemented it. We take our enrichment response Pydantic model and call model JSON schema on it. That gives us a JSON schema compatible with what Claude expects. We pass that schema as input schema of a tool, and we tell Claude it must use that tool. Force tool use more. Claude returns a tool use block. We parse the input field of that block directly into our Pydantic model. No string parsing, no JSON loads on fast code block, no regex to strip to pose that appeared before the JSON. One more thing, we set the tool to force mode, meaning Claude must call the tool. It cannot respond conversationally. If we allow conversational fallback, we are back to string parsing. Let's look at the client wrapper code. Look at the tool definition. Use Claude's tool use feature to force a type JSON response matching the enrichment response schema. The raw dictionary is returned to the caller. The route layer is responsible for constructing and validating the Pydantic model. Look at here. Model, JSON, schema. This is the tool choice forced. Parsing the tool use block. Force exactly this tool. No free text. Fallback is not. Look at the tool choice. And tool blocks are tool use and enrich title. If not tool blocks, we will raise a runtime error. Claude return no tool use block for enrich title. And we will stop and return. Or else we will call the tool. This is a system prompt. This is an enrich tool description. Claude returns a valid JSON, but we still run validators before it leaves the service. Structured output gets you a long way, but it is not a complete substitute for validation. JSON schema can enforce types and required fields. It cannot enforce business rules. It cannot catch a confidence value of 0.02 that technically satisfied the numeric constraint but signals that the model had essentially no idea what the title was. It cannot catch a summary that is a valid string but is 50 words of filter with no useful content. It cannot enforce that a warning list only appears when confidence is below a threshold. That is where Pydantic field validators and model validators come in. We add 3 validators to enrichment response. First, confidence must be between 0 and 1, handled by the field GA and LA constraints. No custom code needed, as you see here. Second, if confidence is below 0.5, a warning must be appended automatically, handled by a model validator that runs after model construction and adds a low confidence warning if the field is missing. Third, genres must have at least one entry, handled by field validator that raises a value error on empty list. This catches the case where Claude technically returned a list but included nothing in it because the title was completely unrecognizable. Validators are not overhead. They are last line of defense before LLM failure propagates to your caller. Look again to the enrichment response. We have a field validator for genres. If we deliberately feed a bad response, an empty genres list, the validator rises. Genres must not be empty, or genres must not contain blank entries. And we have test rows that test kind of behaviors. Request validation, then after comes to response shape tests and the contract signal tests. We will come to that. Now let us put this all into a FastAPI route and wire it together. The FastAPI route is where all three layers connect. The route is a single post endpoint at /API/enrich. It receives an enrichment request and returns enrichment response. Those two types are public contract of the service. FastAPI's response model parameter does two things. It validates that the object we return actually matches the declared type. If we try to return something with a missing field, FastAPI raises before the response is sent, and it filters the response. If our internal model has fields we do not want to expose, like internal debug data, they are stripped automatically. The route itself is short. It receives the request, calls Claude a wrapper, passes the test results through Pydantic model construction, which triggers the validators and returns the type response. If anything fails, the Claude call, the schema parse, the validator, FastAPI returns an appropriate error message. No unhandled exceptions, no error exception text leaking to the caller. This is the service boundary in practice. Clean in, clean out. Look at this router post decorator in the routes PY under the API. The response model is the enrichment response. If we run the application and check the Swagger user interface, we see the health is okay. And look at this enrich media title structured metadata. It looks like that, and it can be consumed like this. A successful response will have a title, genres as an array, a summary, a confidence, and warnings. The one pattern I want to make sure you take away its confidence plus warnings field combination. Most APIs have two states, successful and error. For AI APIs, I add a third uncertain success. An uncertain success is a response where the service returned a result, but the model was not confident. The caller needs to know that. Maybe they display the result with a caveat. Maybe they flag it for human review. Maybe they fall back to the default. That is the caller's decision, but only if you give them a signal. The confidence field plus warnings list is the pattern. Confidence is a float from 0 to 1. The model self-assigns it based on how well the context supported the answer. The values above 75% are reliable. Values between 50 and 75% are usable, but should be treated with care. Values below 0.5 should trigger a warning and possibly a fallback. Warnings is a list of short strings, plain English notes for the caller. Input title ambiguous, match partial result, confidence below threshold, genre classification is uncertain. These are not errors. They are metadata about the quality of the result. The validator adds low confidence warning automatically when the confidence drops below 50%. The Claude prompt is written to produce warnings when the input is ambiguous. The caller receives both result and the signals they need to handle it appropriately. This is pattern travels well. You can apply it to any AI API that has uncertain output. Summarization, classification, extraction, translation. If we go to confidence test PY, we can see what is high confidence, low confidence, and invalid empty journeys. Look at the mock data of the high confidence. It's a movie, Inception. It's a sci-fi, it's a thriller. As skilled thieves enter the dreams of others, steal their secrets. Good. Confidence is 91. Low confidence. The Entity. It's a horror movie, partial match found. Title may refer multiple words below 50. The title match multiple entries. What can you say? Title unknown, no metadata. Look here. If we have warnings and confidence is below 50%, we throw a message, a warning message. So the frontend or downstream service can branch on warning length. Let me close with how to test this kind of API, because the standard request response tests need a different approach here. Testing an API is different from testing a deterministic API. If you assert that the summary field must equal a specific string, you will fail every time the model represents. That is not useful test. What you can assert is structure and thresholds. For structure, every response must have a title, genre list, summary, confidence, and warnings. None of these should be null. Genres must have at least one entry. Summary must non-empty string. These are deterministic assertions. They pass or fail the same way every round. For thresholds, for a known clear input, a well-known movie title with unambiguous genre, confidence should be above 70%. If it drops below, something has changed. The prompt, the model, the context. You want to know that. For the warning signal, for a known ambiguous input, a title that could be a film or a product, the warning list should be non-empty. You can assert that low confidence branch fires correctly without asserting the exact warning text. This is the same evaluation harness pattern from episode 1 applied to the API boundary. It gives you a regression signal without brittle exact match assertions. Let's go back to test roles py. Look at the shape assertions. It tests the title is string or not, tests genres list, tests the summary, tests the confidence is a float and it's in range. And as you can see for the episode 2, all test roles are passing. You can run it also on your own. You can get the code from the AI Engineering Lab GitHub page, run it on your local with py test, and you will see. Let me close with 4 things take from this episode. 1. Design Pydantic models first. The models are contract. Everything else, the Claude call, the road, the validators, is implementation of that contract. 2. Use Claude structured output via tool use, not prompt engineering. Force tool use mode. Do not allow conversational fallback. This is the difference between a constraint and suggestion. 3. Validate the service boundary. Pydantic validators are not overhead. They are your last line of defense before LLM failures propagate to the callers. Business rules that JSON schema cannot express go here. 4. Test structure and threshold, not content. Shape assertions are deterministic. Confidence thresholds give you a regression signal. Exact match assertions on LLM text are brittle and should be avoided. The full code is in AI Engineering Lab. Branch to FastAPI Pydantic Claude. Link is in the description and I showed just before. You can get this repo by yourself. In the episode 3, we are going to build a browser automation agent using Playwright and Claude. An agent that reads live web page, decides what action to take, and executes it. The same observe, decide, act loop that powers production web page agent. See you there. And before you go there, don't forget to subscribe and like this video. Thank you.